Okay, in Teams and OneNote, I have put in a periodic table for you. So pause this, go grab the periodic table, have it handy, print it out, do whatever you want, just to get your periodic table ready. Okay, now that you have it ready, we're going to use your periodic table to draw something called a Lewis structure. A Lewis structure is the location of the electrons in an atom, but more importantly, only the electrons that interact with other atoms, the ones that are on the outside. So those have a name. Those are called valence electrons. So when building a structure, you got to, using your periodic table, you've got to determine the number of valence electrons. Again, these are the outermost electrons. Make sure that you know that. That's very important. Once you know how many valence electrons, that's how many electrons that you are actually going to draw for that. Okay? So the key for doing this is looking at the groups of the periodic table. Right here, I've got all of these colored. I've got the first, second, 13th actually has got 3 valence electrons, 4 valence electrons, 5, 6, 7, 8. These are the transition metals. They actually have variable structures, so the same atom can actually have different structures, so depending on things. So we're going to skip right over those. So you need to use the periodic table to figure out how many valence electrons. So what I just wrote out here is on here. Everything in group 1 has 1 valence electron. Group 2 has 2. Skip the middle. Group 13 has 3 valence electrons. 14, 15, 16. So group 16 has 6. 17 has 7. And group 18 has 8, except for this little exception here. Helium has 2 valence electrons. So just know that in chemistry, for every single rule I teach you, there is an exception, except a couple of rules that don't have exceptions. Okay, so when you're doing a Lewis structure, you're going to write the symbol. So the symbol here is our carbon. It is in the 4th, okay, this says 4th group, it's the 14th, but if you're ignoring that little middle section, you just say the 4th. I'll show you in a minute. So 14th group has 4 valence electrons, so we have 1, 2, 3, 4 valence electrons. Now the interesting thing is you place them exactly like I just numbered those. The first valence electron goes on the right-hand side, and then the second and third and fourth, you go counterclockwise. So checking your work is just making sure that it is in the 14th group of the periodic table. Now the reason that said 4th group is because this little mini periodic table here is literally cutting out the transition metals. So the transition metals go on the side there. So I think I've got it on, yeah, right here. So the colored ones in this picture correspond to the ones written on here, and the transition metals, we just cut them out and jammed it together. Okay? Don't you miss that sound? So this page right here is in OneNote. So go over to OneNote, get this ready, and we're going to draw these together, and then you'll have a practice worksheet to do after this. Alright, now that you've got OneNote set up and you're ready to go, drawing is the best. I don't know why the bell rang twice. Drawing is the best. If you have to draw with your mouse, so be it, but that's probably the easiest, fastest way to do it. So everything in group 1 has 1 valence electron, which is written on the right-hand side. You'll notice right here in this box, I'm pointing over here by the way, the first electron goes on the right-hand side. The second one, if there is one, which there is not for group 1, but the second one would go on top. So everything in group 2 has 1 valence electron, 2 valence electrons, one on the right, and then go counterclockwise, put it on top. So that's group 2. Everything in group 13, or the way that this is written, is kind of like group 3. That's why it's called 3A, 4A, and so on, if you saw that on some of your work. Everything here has 3 valence electrons, so one on the right, and then you go counterclockwise. So everything in group 13 looks exactly like that. Group 14 has 4 valence electrons, and you'll notice that I'm starting on the right and going counterclockwise. Group 15 has 5 valence electrons. Now I just ran out of space. I did 1, 2, 3, 4 around, and now I start pairing them up as needed. So everything in group 15 is going to look like that. Group 16 has 6 valence electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Everything in group 17 has 7 valence electrons. So we end up 1, 2, 3, 4. Yes, I have 7. So 1, 2, 3, 4, 5, 6, 7. That one's a little bit neater. And then group 18 has 8 valence electrons, except for helium, which only has 2. And you do put those together because there's nowhere else for them to go. We'll learn more about that later. So everything else, though, has 8 valence electrons. So 1, 2, 3, 4, and I think you can see that this is relatively easy, and you're probably going, what's the point? Little hint in chemistry, sometimes you're not going to know the point until a few lessons later when you kind of put it all together. We just got to take little steps. Another hint about chemistry, it is a participation sport, not a spectator sport. You have to put pencil to paper and do the work. That's the only way that you're going to learn this. So now that I've filled that out, which is in your notes in OneNote, below that there's a worksheet that you need to fill out, and that should be pretty easy for you to do. Have a good day.